We want to see you go over on the short right. A lot of 3s and 4s and some 2s, so we'll do those 3. This one can be done in Desmos. If I make a table and add all of those in, as I'm looking at all of the points, they don't make a line that goes to the origin, so it can't be direct. One side kind of looks like it's making the hyperbolic curve, but the other side doesn't. So I would say neither based on the graph, but just to make sure, I would check this. If I start dividing, I check for direct. This would be 2, 2, -2, so not direct. If I multiply, 8, 18, so not inverse, so it is neither. And if you use Desmos to figure that out, make sure you use Desmos. Number 3, you have to know your linear transformations, what each part is talking about. So first I'm going to find the equation of this original, which was y equals 2/3 x plus 3. And then if the equation has been reflected, that's your slope changing, so now it's a negative. And if it's shifted down 2 units, your y-intercept moved down 2, so now this is at plus 1. So your new equation will be y equals negative 2/3 x plus 1. Questions about that?
If it's reflected, we're going to have we're going to have negative reflected.
So that only affects the slope. Reflected affects the slope. So Alright. Or number 4, you're really just combining like terms, adding the 2 polynomials together, and there are only 2 like terms that you can combine. So this would be 5x to the third minus 6x squared plus x minus 10. You could check that in Desmos by putting in the original, changing the x to either a capital X or a different variable, and then putting in the answer and seeing if they match, the decimals match. Any questions on that? Make sure your name is on your short right hand. I think the last page is for this practice. Did we have any other questions on how we use the distributive property before we talk about dividing radicals today? So when we divide radicals, you could do this a couple different ways. It really depends on if the numbers are perfect squares or perfect cubes if it's a cube, or if there's something completely different. We're going to end up simplifying, and then sometimes we end up with a square root in the denominator, and in math, just like some of the other specifics that you need to do in math, you don't usually see radicals in the denominator, so we do something called rationalizing it. And I'll put them. So in number 1, if both of these are perfect square, you could think about this like the square root of 49 over the square root of 100. And you would just take the square root of both, which would be what? What's the square root of 49? 7. And what's the square root of 100? 10. And that would just be it. Sometimes the numbers aren't perfect squares but can be simplified. So like at number 2, these aren't perfect squares, but I could simplify this because 8 goes into 32. What would that simplify to be? 1 over 4. And these are both perfect squares, so I could do the same thing. And this final answer would be 1 over 2. Sometimes you get a partial. So if I split this, we have the square root of 3 over the square root of 16. Square root of 3 we can't simplify, but the square root of 16 would be 4. Or can be done a couple different ways. I'll show both. So we could separate it. The square root of 7 we can't simplify, but this we know would be 7. However, let's say instead of separating it, the first thing you saw was, well, 7 goes into 49, so I want to simplify it. So that would be 1 over 7. And this is where rationalizing would come into play. So if I separate this, I'd have the square root of 1 over the square root of 7. I know the square root of 1 is just 1. But I can't leave the square root of 7 in the denominator. So what we do is multiply both the numerator and the denominator by the square root of 7. So that, I'm going to do this off to the side. This numerator becomes the square root of 7, the denominator becomes the square root of 49, and that just becomes 7. So you get the same thing both ways, but one is a little bit more work. You have to rationalize it. In some cases, you'll have to rationalize regardless. Do you have any questions so far? Most of these, you shouldn't really have to rationalize. That one was just an example. You could do both. But a lot of these you will have to simplify. So if you see something like 10 over 45, you could change it back to just a whole fraction and simplify, or you can try to simplify both pieces. It's your choice. You do whichever one is easier for you. I'm going to leave this like this because I know the square root of 10 can be simplified more. Using perfect squares, what two numbers could we break 45 into? What's the highest perfect square that goes into 45? 5 and 9. 9 would be the perfect square. So then we have, let me erase this. The square root of 10 over 3 times the square root of 5. And I can't leave that square root of 5 in the denominator. So again, I have to rationalize. So in our numerator, we have the square root of 50. In our denominator, 3 times the square root of 25. But now we can simplify the square root of 50. So maybe it would have been better to do it the other way. Sometimes it's unfair to do it. So I know in my denominator, this would be what? What would the square root of 25 simplify to be? 5. And 50, what's the highest perfect square that goes into that? Can you divide 50 by 49? That's the closest, but it's not the highest. that we could divide it by?
5 and 10.
Neither of those are perfect squares. Say that again. 4 and 5. To get 50.
Oh,
Someone was starting to say it. 20, not 4, but 25 and 2. So we have 5 times the square root of 2 in our numerator, and 3 times 5 in our denominator. You could do a couple different things, either multiply the 3 and 5 and then simplify 5 over 15, or just get rid of the 5s. So that our final answer would be square root of 2 over 3.
Why did you multiply 3 and 5?
You could do that. But then you have to simplify. All of these can be checked in the calculator in Desmos, because you're just going to get a lot of decimals. When you do a lot of work just to make sure you didn't lose anything, I would do that. I'll check this one and then maybe one over square root of 10 over 5. And we got the square root of 2 over 3. And then same thing, that would show you did that right. Pick some others on this page you want to see, you go over, have questions about. Okay. Any others? With 12, because we have numbers on the outside, you want to simplify those. Does 7 go into 84? Can we divide 84 by 7? And you get a whole number. Okay. So then I'm going to rewrite this both as 3 over 15 and the square root of 84 over 7. So that this would simplify to be 1/5, and the square root of, or when we divide this, would you get 12. So that makes it a little nicer. I still have to simplify the square root of 12, and 5 is still in my denominator. I'm going to combine that after I simplify. What's the highest perfect square that goes into 12? 4 and 3. So you have 2 times the square root of 3 times 1/5. So our final answer would be 2/5 times the square root of 3 off to the side, or you can put 2 times the square root of 3 over 5. It would both give you the same thing. Questions, confusions on that? Are there any others on this side that we want to go over, have questions about before we go into the back? Karen, did you still need that? Okay, so we talked about this, but there's the actual definition and how you do it. Multiply both the numerator and denominator by the radical and the denominator, and then simplify. So some of the previous ones, depending on how you did it, you didn't have to rationalize, but these ones you should be rationalizing. I'll start with this one. If I were to rationalize this, how would I do that? How would I get the radical out of the denominator? Multiply by,
7.
not just 7, but the square root of 7. So we have 4 times the square root of 7 over the square root of 49. And that would simplify to 4 times the square root of 7 over 7, which cannot be simplified. And that would be our final answer. Look at some others on this page. Find some other questions you want to see to go over together. Alyssa, did you have one? 19. Okay, and I'll let you guys choose. Do we want to start with rationalizing or do we want to simplify it? Okay. So simplify it by rewriting this as one fraction. And if you want to start off by rationalizing, you could have also done that. If I simplify this, we get what? 6 over 5. Both are not perfect squares, so I'm going to go back and separate it. So I have this, let me rewrite that. 5 times the square root of 6 over the square root of 5. Now I have to rationalize it by multiplying both by the square root of 5. So in our numerator, what would that give us? 5 times the square root of 30 over the square root of 25. Can the square root of 30 be simplified? No. It's one that cannot be simplified. But square root of 25 can. So the 5s are going to cancel, just leaving the square root of 30. If you had started off with rationalizing, you would have multiplied both by the square root of 10. In the denominator, you would have just had 10. And then in the numerator, you would have simplified the square root of 120, which would have simplified down to this. Questions on this? Any confusion? Now would be a great time to ask if something didn't make sense. Are there any others we want to see do go over have questions about? I don't have the practice quiz for this yet. I should Monday. But today is the end of Unit 11. Monday we'll be starting Unit 12. We should finish that by the following Monday, so not next Monday, but the Monday after that, and then we'll start some other units. So for the rest of the class, we will be working on practice from these notes, Delta Math test due today. Remember you guys have 2 that are due today. Past Delta Math, Test Nav, JLabs, practice quizzes are still out.